Welcome back, everyone, and today I'm going to go into another tangent. Right here, I'm going to show you off something I've been kind of played with a couple of months ago, which is like a texture generator. And recently, I kind of showed it off around the internet to a couple of people, and the consensus is that people actually want to learn how to create dynamic textures. And the big thing that people talk about when I show them this thing, they would really love to be able to do something like After Effects. Apparently, After Effects has this really great texture generator. It uses a lot of different type of noise. It uses fractal noise and turbulence and a bunch of other things, and it can animate the textures, and it can do a bunch of fancy things. So you can do a lot of things, and I've seen a lot of special effects tutorials for Unity that uses After Effects to create these really cool looking textures. So I decided to maybe that'll be one of our goals. So we're gonna, in the series, we're also now gonna do a texture generator, and we're gonna work toward making a web-based After Effects, fractal noise generator thing, where you can combine a bunch of things, a bunch of noises and values, and eventually output dynamic textures that you can save to your desktop or even maybe animate. So that's probably the end goal. So I have a lot of things that this series is now starting to cover, armatures and voxels and other little things. So I know it's going to be a little crazy, I'm bouncing around a lot, but this seems to be something that a lot of people want, and it's probably going to be very useful for us to do effects with it too, if we can generate textures. So I'm going to show you off something I built a couple of months ago. It really just takes Perlin noise and does them in different octaves, and it auto-generates a texture. And I created kind of this little thing that kind of shows you the 1D wavelength of what you're generating. So if I increase samples only gives me the actual value that I'm outputting on this 1D thing or 2D, and as you see, as the wavelength changes, so does the texture. And the idea is that you take the exact same texture or the same wavelength, and you do it at different resolutions, and that's what octaves are. And in the end, you somehow combine them, and this will be the final example of the combined octaves. And sometimes you can do more than 3 octaves. You can do 5, 7, or whatever. And let me bring it down. So as you can see, you have this very smooth starting point, and then the lower version of it, it's a little bit more bumpy, and it gets even much more bumpy in a 3rd octave. You kind of just combine them in any form. There's so many different ways you can combine them. You can average them out. You can just add them together. Each one might create a different effect or a different type of texture. And as you can see, like I said, this is smooth, and the overarching shape is there, but the other 2 octaves end up making it not as smooth. And things like this is used for creating terrains as well. So this is also for terrain generation, especially when you're dealing with octaves, because this creates an overall hilly shape, and this creates the smaller hills, and this ends up creating the rocky parts of your hills. And when you combine them all, and with different weights, I guess, if I add more weights to it, I can actually control how heavier these lower octaves have on the beginning octaves, like how much strength the lower octaves have on the higher octaves. You know what I get. The 3rd octave has more strength or has more weight when applied to the 1st octave. It makes it more rocky, more shaky. And you can do a lot of things, and a lot of these are different values. And as you can see, you just end up creating new textures. And so if I take persistence down, so this way you got some stuff like that. So we're probably going to build this. Like, we really don't need this, but if you guys really care, in the next video I can show you how this part is built. But for now, for this video, as a starting point, since we're going to try to make a big old noise generator, kind of like After Effects, we got to know how to build the textures and just deal with one single bit of noise. So we're going to go to some code, and I have created a new folder called TextGen that's at the same level as Fungi and Extra. And Extra has our noise module that we used before. And TextGen eventually will use our WebGL stuff, because I might end up making it render everything in WebGL, especially when I want to animate it. So, but for now, everything's going to be under this folder because it's something that it's going to be like an application that uses Fungi. So that's the reason why it's going to be separated from our WebGL stuff, because it's not dependent. It shouldn't be part of the core. So that's the only big difference. And in here, you'll find the original code that I created. I just showed you. If you're really just curious, I'm actually going to redo these and make it smarter, because the way I put it together was kind of a big mess. But if you're really curious, if you go into TextGen and you go under _origin, you'll actually get to see the one with the sliders, and you can play with it. You can look at how the code is. But for now, we're just going to do a very slim version of it, and we're just going to create a simple texture. So the first thing we need to know is how do we generate textures? So to generate textures, we need a canvas. And just like with WebGL, we have a canvas, but this time we're just going to get the 2D context instead of the 3D context. So this way we don't need to do too much to grab the context. So I created a class called Texture Canvas. You pass in your canvas ID. It does the same stuff, but like I said, it gets to 2D context. We get the width and height, and we grab its image data, which is kind of just like an overall reference to kind of like the image information. And then we grab the data, which is like the raw array. And the array is basically the same thing as our 4-component vector array. So the array is like 4 components per element. But it's a flat array. So the first color takes the first 4 elements. The second color takes starts at index 4, 3, 4, 5, and 6. 4, 5, 6, 7. So it's like I said, it's like how we dealt with raw arrays when we're doing vertex data. We're doing it with color, and that's how we have to access it by image data's data property. And to get a pixel is very simple. Like I said, we just calculate its index. We've done things like this before when we're dealing with flat arrays, and we access it this way. So this is like no different. We've done this a lot with WebGL. And set pixel is the same thing, except we're setting the value instead of pulling it out. And when you're done setting all the pixel colors, you have to kind of put the data back in. So you grab the image data that you have the reference to. It basically kind of creates a copy of an array. It's kind of like if I'm going to make this related to WebGL, I would say that when we say get image data, we're kind of getting our own custom frame buffer, and then we're kind of rendering to that frame buffer, and then we're all said and done, we're going to push that data back to the main buffer. So that's essentially what's going on for the most part. And I have one more function that shows you kind of how to kind of download the image file, which you just take the canvas has a function called toDataURL, and it creates a data URL, and then all you have to do is kind of replace the MIME type to image aux string, and then you can just place it into, I think, RHF, and you can kind of automatically start downloading it. If you do not do the replace, you would automatically display the text, and you can just right click and save the texture. So this is, like I said, I created something simple that gives us a little bit of everything that we need. And we have one more function called smooth step. And if you remember smooth step when we're dealing with shaders, GLSL, this is what it is. This is all the math for it. I found online what's the math equation for smooth step. Here it is. So we can kind of use this in JavaScript. Like I said, we're doing all this texture stuff purely in JavaScript. We're not using WebGL at this point. We will probably in the future. So the first thing, like I said, we got to do is we got to get our texture context. And then we're going to have to get its width and height. And I'm inverting the value so we can do multiplication. So at this point, here we have x times w. It's really x times divided by w times s. So But since I'm inverting it, I can do multiplication, and I've been saying this for practically almost a year now. It's just optimization. Since I'm doing a bunch of math in a huge loop, every little ounce helps, especially since you're dealing with so much data. So you're better off with multiplication than division. Then we have N, which is our noise results. C is for color, and S is for scale. How much do we want to scale our Perlin noise? So when we're grabbing our Perlin noise, like I said, we're going to grab a value for every X and Y position in our texture. So our texture has, is, how big is it? Is 256 by 256. So that times that is how many pixels we have. So that's how many times we're going to call Perlin 2 and get a value that we're going to output. And Perlin always gives you a value between 0 and 1. It's just noise. So once we have some noise values, we're going to multiply it by 255. And that gives us a color. So, and then we set the color and it becomes a grayscale value. That's all it is. So set pixel, put the X and Y position that we're at, put the color, and the last color is alpha. So we can set alpha if we want, but we're going to set it as a solid color. So with this all said and done, you don't need this anymore. This is the texture we get. It's probably hard to tell, but there is some little bit of white here. Now, the reason why we can't really see too much, I probably shouldn't have closed that. As you see, there's a line, and that line is 0. So Perlin noise is like a sine wave. It can give you a value that's over 0 and under 0. Yeah, like that, I guess. More samples? No. There you go. So this is what Perlin noise looks like. So if we're getting like a value going up, we're getting 1. If we're getting closer down here, we're getting like a -1. So the reason why we can't see too much is because there's actually a lot of negative value around this area. So when you're dealing with textures, you can do a lot of things. All it is just numbers that you're playing with. So you can play with it a lot any way you want to. So since I know there's a lot of negatives, why don't we just go back, force it to everything be positive, because we can't have negative colors. So any negative colors end up becoming black. So we just do an absolute on N and we save it back out. And now we can actually see the overall texture that we're applying. Just imagine everything being shifted above the line. That's all we're doing when we do an absolute. So now we have a texture, and the only thing we can do at this point, if we want, we have a scale value. Right now we're scaling by 0. That means we're going by every X divided by its width. So we're going to do like a fraction of its width. So this way, so the point is that at this point we're at 0, and over here we're at 1. So we're kind of doing like UV value. So here for 0 and down here is 1, I believe. I know in UVs it's this way. You start at this corner and you work your way up. But so that's the cinch of it. So okay. So now that we have some basic textures, we can actually play around with it. It's very blurry. Well, let's play with scale. So if you want, you can scale the value. We can scale it by 5. And basically what it kind of does is it kind of zooms. So let me go, okay. Let me go back to 2. Like I wish I had a slider so we can zoom in and out. Well, that's 2, right? Yeah, that's 2. So originally we were here. Like we had that little spot and we had this spot. Now we're at scale 2. Now that's zoomed out and we're like zooming out more. So every time we scale, we're actually zooming out. If I want, let's say if I go back to 1, you see now we zoom right back into like the scale of 1. If you want, you can actually scale. You can zoom in, go under 1, and that should zooms in. Oh no, don't select. There we go. So that's what we're doing here. We're basically going around Perlin noise, and just changing the scale as we go through each pixel. So now with that saved, we're back to this. Now we can control it. So if we want, we can scale it even further. So we can actually scale the value. So by scaling a value between 0 and 1, we're trying to make it wider. Basically, we're trying to make anything that's white wider. Anything that's black stays black because you're doing multiplication. If you do 0 times 5, you're going to stay at 0. So anything that's greater than pure black gets multiplied. We're going to increase its color. And here we go. So everything here that's black is really pure black. It's like an absolute 0 or very close to 0. And everything else got multiplied by a lot. And everything here in the center was actually close to white, and it just got blown to the maximum. So now everything here is at a value of 1. You can control it even further. So let's say, okay, now that we multiplied it, if n is less than 5, 0.5, make it a 0, else make it a 1. So basically, you want to get rid of all the blurring. And there we go. Now it's kind of like, pixelated. But now we completely took out any blur. We made it a simple black and white image, purely, no grayscale. But if you want that grayscale, that's why we got smooth step. So smooth step tries to turn anything less than 0.4 straight into 0, anything greater than 0.6 straight to 1, and anything between gets faded. So there you go. So we get that kind of like anti-alias kind of effect. We can smooth it out even further if we want to do something like I think 5.5, like a really small window of fading. You get a pretty good anti-aliasing effect going. So that works out pretty well. Let me leave it zoomed down. I should have done this in the beginning. So you can do a lot of things. You can, let's say, a very wide fading. So you can kind of make it kind of blurry. You can control how blurry it is in this transition between black and white. I'm going to keep that. And don't forget, other things you can do is inverting. You can invert. Just do 1 minus, and you just completely invert it. We've done this before in shaders. White becomes black, black becomes white. Very simple. Let's see. At this point, like I said, you can do a lot of fun stuff. Let's say we zoom out. Let's do like 5. And like I said, we're zoomed out. We were at this section over here originally at 1. Now we're kind of zoomed out, and it created this pretty neat texture. That's because we got that smoothing. Like if we wanted some more blurring, you got some blurring. If we don't want to do absolute, include the negatives. This is what it looks like. We can invert it. Let's see, where did I have it? Let me see, 7. I had something pretty cool looking before. I feel like, that's right. I got absolute. There you go. Yeah, so with that back absolute, we got the scale of 5. We're doing a little bit of smoothing, and we're doing an invert. We end up creating a texture like this. And when I generate this texture, I was like, oh my God, you know what I can do with this? If I had like a really high level, or not high level, very a plane with a lot of vertices, I can use this as a height map and then end up creating a maze using a plane. Any part that's, white, I can make it like a floor. And anything black, I can make it into a wall. So as I'm going through pixel by pixel, if I make this like even, like 1-to-1, like every pixel gets a vertice, I can then turn this around and make this into a mesh and actually make basically a maze. So this, like, we can then create mazes and terrains and whatnot, like using this as a height map. I noticed I know I was playing around before, so let's see what some of these do. I forget. So if I do that, set that to 7, that's probably what creates this texture, or create something different. That's cool. I don't know. I guess I thought that was cool at the time. Let's try this one. This one, I say set the scale to 20. So let's see what this looks like. Like, I don't remember. Refresh. Ooh, wow. That's still pretty neat. Let's see. It'll probably look better if I inverted it. Refresh. Ooh. Probably should only invert it after the fact. Yeah, like that. Like a really detailed maze, And the thing is with Perlin Noise, you can keep scrolling left and right. So ideally, like if you were going to create like dynamic meshes or dynamic, terrain, you would do them at chunks at a time, and you just keep going left or right, and you would end up can build like this maze. You can actually end up making like an unlimited maze. And I like RPGs, so this doesn't necessarily have to be a maze. This can be a dungeon. This to me can be an unlimited dynamic dungeon that you're just constantly walking around, and every once in a while, you walk into a room, you got some treasure chests, you kill some monsters. So, doing something like this, you can do some really cool things. So, yeah. That's really the gist of it. Like, that's really all I wanted to do for this lesson. Just get the idea of building textures and playing with it. There's, like I said, there's a lot of little things you can do. Like I said, we did a lot of little things. We can do scaling. We can just control the overall flow of the value between 0 and 1. We can crop it. Like, you can actually change. I know I did that. I forgot. Let me try that. We're going to scale this. So what does this look like again? Refresh. I got to probably put this back to like 7. So yeah, you can. It doesn't have to be 5. You can say 2, and you can make things a lot more wider. You like make the walls more thinner. Like, let's say if I wanted to make this into like an RPG like dungeon thing, maybe I need the walls or the roads to be thicker. So just by switching some values, I made them a little wider. So there's more movement. This feels more like a room, and you got these weird things. So you like I said, just by playing with the numbers just a little bit, just think about the little tidbits that you can do. You can always go to shaders and that's because I'm using that. So yeah, let me see. Let's say between 8 and 9 should create the same effect, but with the smoothness. Yeah, see, a little bit smoother. Do 7.5. There you go. If I could do Control-0. So nice and smooth texture. Looks pretty nice. It only looks a little jagged because I have it zoomed in. So yeah, like I said, you can do a lot of things. Scale, you can multi-scale, or you can divide. You can add. You can do things like look at the previous pixel and change it up based on that. Do a multiplication, do a division. What else can you? Like I said, there's so many little things you can do just to throw in there. I haven't actually even tried. Can I? Nah, I don't want to mess around with it. I was going to try to see if I can grab the previous pixel, but and just maybe add together the nulls. Can I don't know, why not? Var pre equals 0 at the end, p equals n. All right, let's see what that looks like. Did I do that right? Oh, pre. You know what? Screw it. Previous. I'm going off script basically. I don't know what the hell I'm doing. So I'm saving n to previous. So the next loop. Let's try p. Instead of 5, we're just going to multiply based on the previous value. Let's say math dot max p, because maybe the previous value is 0, and then that's no fun. Yeah, let's do that. You have to have a minimum, and it still doesn't work. Oh, you know what? Because I need to scale. All right, you know what? Let me scale first. Scale, right? Scaling. Okay. Now let's say n plus equals p. Like I said, I don't know what's going to come out of this, but that's the whole point. It's experimentation, and it makes everything white. You got a little bit of black. How about, I don't know, max dot min, or I should say max. Like I said, I don't want a value of 0. 0.5 maybe. No, not 0.5. 0.2. Refresh. So basically, I made myself a fool. I don't know. P. I know there's. Like I said, I don't know what I'm doing. This is what I just do. I just play with numbers, see what happens. End up creating the same texture. I don't know. Half of that. Still creates the same thing. Also, I suck. Well, how about I do this minus? Does that work? Does that work maybe? Give us a value. Does that change the textures around? Oh, well, there you go. We got something. Awesome. We got something. Like I said, just keep trying. Something might pop up. You have no clue. Like, I have no clue how this works. Look at that. But I got something very interesting. Like, okay. All right, minus if we do subtract. All right, now we're on a roll here. Let's mess around with 2. Okay, that's cool. That's kind of neat. Increase the value. Like I said, I don't know how the numbers, because I'm not really thinking about it. I'm just throwing numbers around. See, now I'm just going batshit. Shoot, I can't curse. I'm going to demonetize it again. Oh well, life sucks. All right, but yeah, look at that. That's pretty cool. I don't know about you. Now I really want to play. Now this video is going to be way too long, and people are going to complain. I'm sorry. Yeah, let's see. Now I'm trying to remember, what was the scale? Let me lower the scale a little bit. Nah. Maybe raise the scale? Oh, you know what? That's right. I want to raise this scale. Refresh. There you go. You know what they're starting to look like? They're starting to look like cells. Or, oh, what's this? I think this is called tone shading. Not tone. Oh, it's that manga stuff. Manga tones. Screen tones. There you go. Screen tones. So I inadvertently created screen tones by accident. So I created screen tones. So basically, I don't know. Like I said, now I'm just curious. See, and I see now you're stuck with me. Refresh. See that was fail. That was a failure. Back to negative. How about a plus? Refresh. Still no good. So I guess it works out. Negative is a good number. So by doing that, I end up creating some kind of weird tone effect, and it changes too. I don't know what changes it. Like I said, I don't know what the hell is going on. Times X. Okay. Oh, you know what? Divide by X. That's going to be scary. Back to black. But you know what? Maybe plus does a better job. Nope. So how about I just stop before I make myself a real fool? Because I managed to get something pretty good just going off the rails. Let's end it here before I make a bigger fool out of myself. But like I said, just play with numbers. Just come up with ideas. Just throw it in there. Just mess around. If multiplication doesn't work, try addition. Try subtraction. You never, like I said, you never know what you're gonna get. It worked out. I managed to get something, and it's kind of neat. This is a pretty cool texture, I guess, essentially, that we were able to do. Yeah, I think there's a lot of black, and I think that a lot of that black kind of screws things up. That's why I kind of needed that minimum. Don't they have that minimum? I thought I did. Oh, because I'm just doing subtraction. Oh, okay. But yeah, a lot of this black colors, when you do multiplication, it ends up negating everything else. So that's why you got to be careful with zeros. Zeros, multiplying something just makes more zeros, and that makes black. But yeah. So yeah, if you see a lot of black, that's the problem. If you see a lot of white, you're oversaturated. You got to bring the values down a little bit. But overall, there you go. Like I said, it's just mess around. I guess I'll save this as the final version, and I'll put this on GitHub, so this way you guys can see the really goofy texture I made. I guess maybe I'll make this the texture or the image for the thumbnail. So yeah. Short. So basically, we're going to build a texture generator. And this is the beginnings of it. We're just messing around. We're getting the idea of how to deal with it. Next video, if you really want, we can focus on. I want to focus on octaves, because you create some really funky textures when you're dealing with octaves, and you have luminous. I can't pronounce that, and persistence and weight and things like that. Frequency is what that's offset. Base frequency is basically this part. It's just y times h and x times. That's all frequency is. It's just how much do we move throughout Perlin noise. Aptitude, it's only to make this 2D a look. Same things with samples and aptitude. So those three are this, and frequency offset. It's kind of like the starting point, essentially. Oh, this one. So you can start with like x1. Instead of starting at 0, you can start at 1 or 2, whatever. It's just the starting offset for your frequency. So if you want to do chunks, that's what you would you do frequency based on that. And these three values are based on octaves, like merging everything together. So in the next video, I want to really just focus on doing maybe 2 or 3 octaves and generating a texture. Maybe with or without sliders. Tell me if you want me to make this interface. Do you really care about seeing the waves and the texture at the same time, or you just want to focus on the texture? So, because this, like I said, after this we won't be using it, because it becomes very irrelevant once in the end. It really does. Like being able to see this is kind of cool to get the idea in your head, but overall this is kind of pointless, because this doesn't really exactly represent this, because this is 2D. And we might be using, this is actually 1D, because we pass an X and we get a Y. Here, this is actually 2D. We're passing X and Y, and we're getting a value. So, like I said, this doesn't necessarily represent this very well, but it helps you visually know what's going on with the numbers. It's like a visual tool. That's all it really is, just to get the idea. So tell me if you really want to show this, if you don't care for this part and we just want to deal with the octaves and actually texture and texture, the video will probably be smaller, less to deal with. So, like I said, all this code exists in GitHub for this episode, so you can actually see this and how this works if you really care. Like I said, this is not WebGL; it's not really that important. But texture generation, it can be related to WebGL, and it pertains to this series a lot better than just doing these 2D stuff that's not in WebGL to begin with. So I probably spent too much time on a very simple topic. Some people complain about that. Sorry about that. If I spend too much time on a simple topic. Yeah. So overall, I'm kind of happy because I did end up getting a cool texture at the end, something I didn't have to begin with. Like I said, this is going to be a series. This is going to be a new part of the series, creating textures. And like I said, we're going to focus on trying to make something as close, if not better, hopefully something at least half as good. But it'd be awesome to make something better than After Effects. Their noise generation, textures, stuff, animations and everything else. I already have an idea how to do circles, so we can do things like that. Like I said, in the end, we're going to everything to be generated through WebGL, so we can do animations and things like that. And maybe use different meshes to render the textures. So this way we can do some fun stuff like if I use a circle, then we can do kind of like a circle. So instead of everything being a square, everything kind of goes around in a circle. I could actually get a completely different look, which might be really neat. It might be great for magic spells and things like that. So you'll be able to make some really cool textures if we start doing different types of meshes that apply this texture. So we end up creating like a texture in the background and then apply it to a mesh and then see what the end results look like. And we can end up outputting that as an actual texture image that we can then use in WebGL to do some really cool effects. So again, tell me what you want to know, what you're really curious about, what you want this part of the series to go, in which direction. Like if there's some noise functions you want me to kind of bring in to see if we can mix it in and add some things. If you have some experience with this, please share. Because like I said, let's make a real application, a real tool out of this, something that everyone can use online, and it'll be free and open source. Yeah, that's how I roll, free and open source. So let me just finish this because it's way too long. Please like and subscribe, and I'll see you in the next video, which is going to be about a little challenge. It's going to be about ISO views. I did a little challenge, and it worked out pretty well. I can't wait to make that video. So see you guys in the next video.